Greetings to everyone. In this lecture, we shall look at the Young's double slit experiment, more so its derivation. So we are having a source of light waves somewhere here, and as to give out light waves, some of them pass into this slit A and this slit B, because this one is a slit and this is also a slit. The slits are separated by a distance d. So these waves are seen to interfere at a point P. At a point P, and if that point P is at a distance y from this line here, which we call the point of the central maximum. This is a distance y, distance from the slit to the screen. In fact, this is the screen. So you're saying that A and B are slits. The distance between slits A and B is given by d, and also the distance between slits and the screen is L. Consider a point where light waves from A and B interfere. I'm considering a point P where light waves from A and B interfere. Let R1 and R2 be the distances covered by waves from A and B respectively. Now, what is the path difference? The path difference is, this is the path difference, because this wave here traveled this path and this wave here traveled this path. So if I get this one minus this, I get this small s, which is the path difference. So we shall have the path difference s is equal to R2 minus R1 is equal to R2 minus R1. Yeah. So now if I look at this triangle here, it shows me that from triangle BAD, we shall have that sine theta is equal to BD over AB. Sine theta here will equal to opposite over hypotenuse, and this is our opposite over the hypotenuse here. So but this one, but BD is the path difference S. So we shall have that sine theta is equal to S over AB, and also my AB is equal to D. So we shall have that sine theta is equal to S over D, implying that my SC is equal to, our S here will be equal to D sine theta. So if I get this S and substitute here, you'll have that D sine theta is equal to, D sine theta here is equal to R2 minus R1. So I say for constructive interference, D sine theta, which is our path difference, is an integral multiple of the wavelength, where m is 1, 2, up to infinity. Also for destructive interference at a point P, the path difference, which is our d sine theta, is equal to m. It is an odd multiple of the wavelength. For m equal to 0, 1, 2, up to infinity. So these two derivations are important regarding Young's double slit experiment. I can also look at the diagram. If I look at the diagram, I can look at this angle here is theta here, this one here. So if I get tan theta, can be equal to, tan theta here can be equal to y over L, implying that my y can be equal to L tan theta. But we know very well that Tan theta is equal to sine theta for small angles in radians. For smaller angles in radians, implying that y will be equal to L sine, implying that y will be equal to L sine theta, will be equal to L sine theta, will be equal to L sine, will be equal to, so I can compare this equation here with the other one, which will say that D sine theta is equal to M lambda. I get this one here, and I substitute here. So I shall have y, and shall have to put sine here, which is actually y over L, and it will give me, if I put it here, so I shall have D, and this is y over L is equal to M lambda, implying that y is equal to M lambda L over D. This is another important expression in case we aren't given the angle. I can look at this one for constructive. So for destructive, I can also derive it, but there is no need. For destructive, I'll just have y equaling to, so just in this one here, it is no longer an odd a whole number multiple, it will be an odd multiple of the wavelength lambda L over D. This is also another important expression for destructive interference. Thank you very much for watching my YouTube channel. Don't forget to subscribe. Bye bye.